Hi, my name is Arnaud Legal, CSE for HPE Aruba Networking, and in this session I will cover two enhancements made to the network analytics engine and coming with AOS-CX 10.16. The first one is the ability to collect outputs of commands used in an NAE agent, and the second enhancement is the availability of the new TCAM monitoring agent. So first, let's start with the enhancement of inputs and outputs capabilities for command actions within an NAE agent. So the original request for this new capability came from a customer who wanted to be able to do the same operation that he currently does on his Cumulus-based devices using shell commands to accurately assess workloads within the data center and adapt port configuration based on various information. So, as you may know, prior to AOS-CX 10.16, one of the capabilities of NAE agent is the ability to pass commands to the hosting device using two different types of commands. So action CLI to send CLI commands, as well as action shell to send shell commands, and which can be used to act on the device based on event captured by the agent. Unfortunately, it was not possible to collect the outputs of those commands for further processing or just to check if the commands have been successful. But now, starting with AOS-CX 10.16, we can collect those outputs using two new functions, action CLI with outputs and action shell with outputs. So what are the use cases for such enhancement? So first, obviously, and as I already mentioned, it brings the capability to process those outputs, especially when CLI and shell commands are filtered using pipe and with Python parsing capabilities like regex and so forth. Then it also allows to collect information in a way which can be sometimes easier than making several API calls. And finally, it also allows to process and read a file which has been stored locally on the device. So this use case brings additional values to NAE, as it means we can easily pass structured and complex information to an NAE agent. While before AOS-CX 10.16, we were limited to the agent's parameter. So having said that, what are the customer's benefits? So first, it will ease some operations when API manipulation could be cumbersome. Then it gives also the ability to make conditional processing based on CLI or shell commands outputs. And finally, it allows to get a more dynamic and complete way to share data with the NAE agent. So obviously, this new capability is available on all CX-based platforms supporting NAE, so the 6200 and beyond. If we now look at the left-hand side of the slide, we can see a quick example of how it works. So as you can see, we simply call one of the two new functions covering this enhancement, giving our command or set of commands as a parameter, and we collect the output into a variable. And as a result, we can manipulate this variable and collect some data coming from the outputs. And as you can see, if you want to print the output, it will be displayed in the device's logs in shell, and this won't be put directly into an alert. So it means that these two new functions do not have strictly the same behavior than action CLI and action shell, which automatically put the outputs into an alert. Okay, so this is mainly the big difference between action shell with outputs and action shell without any outputs. It's how we display the output of the command. So let's move forward now with the details. So first, obviously, and as I already mentioned, if we want to process the outputs, we must put the output into a variable, which will be processed afterwards. Then, obviously, we can combine these two new functions with agents parameters. So as an example, if we want to send a command using the interface name given as a parameter. As I already mentioned as well previously, the outputs from CLI or shell won't be put into an alert using these two new functions. And those functions also allows to process data in the backend, as an example, to parse and manipulate data without having to rely on API calls. Parse or retrieve specific data to be put into logs or SMP traps. To access data which cannot be retrieved using REST calls, and access and read files locally stored on the switch in the SFTP directory. So the last point I wanted to mention is the case of a malformed command. So in that case, the issue can be retrieved using logs in shell. But keep in mind that the error is quite generic. So it will give the set of commands causing an issue, but not which part of the command or set of command is causing this issue. And finally, keep in mind also that these new capabilities are not available for NAE. So it is only in NAE legacy. So if we now look at the left-hand side of that slide, we can see several things. So we obviously have the legacy and simple examples on how to use these new functions, but we also have two additional things. So first, we can see that we are reading a file hosted on the switch. So that file has been pushed to the device using the SFTP server capability, which came in 10.15. So this repository, where the file is located, is at the following path /fs/nos/sftp. So using that path, we can now read a file and collect additional data to be processed using the action shell with outputs and the cat command. And finally, we can also see that we can obviously use agent parameters inside an action with outputs. At the bottom, so you can see the errors which are triggered when the command fails. And so as you can see, this is quite generic. So we can see which function has an issue with the error stating command fail non-zero exit status, and the command or set of commands which caused this issue, but you do not get access to more data. And finally, we can see an example of what could be achieved using these new capabilities. So the goal here is to check if all required elements on our VTAPs are present and properly configured. So we have a JSON file with all required information like the VLANs, the HVIs, layer 2 VNIs, and so forth. And we push that file to the device using the SFTP server. And so the NAE agent, so using a periodic callback, reads this file, check if the different items are locally configured on the device, and if not, it will fix it by creating those missing items. And so in case something is missing, like in this example, the VLAN 50, you can see the logs that it generates in the shell, as well as the alert. Okay, so now let's move forward with the new agent called TCAM Resource Utilization Monitor. So this, the original request for this script came from a customer who were only interested in seeing the graph of TCAM utilization as a function of time. So this new agent is used to monitor the TCAM resource utilization in a AOS-CX switches to avoid TCAM exhaustion. So it supports several parameters like the line card ID, alert thresholds for features, policers, as well as port ranges, and a polling period. So the main use case for this agent is to track the TCAM utilization in real time to ensure it doesn't exceed optimal thresholds. It also triggers alert when TCAM usage exceeds predefined thresholds. So this will allow a user to get actionable insight and so to take immediate action. So indeed, getting an alert means that ACL or policies must be configured differently or moved to another node on the network. So for the supported platforms, as of AOS-CX 10.16, so the supported platforms are the 8325, so it includes the 8325H and the 8325P, as well as the 10K. So how is this calculation done? So there are two aspects to keep in mind. So first, regarding the ingress and egress TCAM entries. The alerts are generated based on the TCAM bank capability. So the agent will generate an alert for a feature of utilization only if the TCAM bank is completely resolved, meaning there are no free entries in the TCAM. Indeed, a feature like ACL or control plane policy will reserve a set of entries, but will not necessarily use all of them. But in case it reaches the total amount of entries it reserved, it can still get another slice of TCAM entries if there are some available in the TCAM. That's why the alert will only be generated if the threshold is reached and in case there is no more free entries for that feature in the TCAM bank. On the other side, for the port ranges and the policers, the calculation is more straightforward. So the agent just divides the current usage by the total capacity to get a percentage. If this percentage exceeds the threshold, like 75%, an alert is sent and a syslog entry is generated. On a more global perspective, it's also important to note that the agent generates logs when it first detects a feature has exceeded its utilization threshold and does not generate new logs in the subsequent polling periods if the utilization has not dropped to a level below the threshold. If we deep dive a little bit into the available parameters, so first we can specify the line card, so we can tell the device or the switch which part of the switch has to be monitored. So on 8225 and 10K, only the slot 1/1 is available. We also have the feature utilization threshold, so the agent checks how much of the reserved TCAM each feature, so ACL or control plane policy, is using. For the policer threshold, it will check if too many policers, which are rules for managing traffic, are reserved. And finally, the port ranges threshold, which will allow to check if too many port ranges, which are used for traffic filtering, are reserved. So just to give a quick overview of a running agent, so two graphs are generated. So the first one at the top allows to monitor ingress and egress TCAM entries, and the second one at the bottom displays the policers and port ranges entry. An important point to note here is that these charts are that of unreserved entries and not unutilized entries. We can also see an alert here because of an issue with egress TCAM entries with a typical message, which will be displayed. And finally, on that slide, we can see that the alerts which has been generated by an agent can also be observed in the device logs using CLI or the web UI. So that's it for this session. Thanks a lot.